You're watching CTOM TV. Knowledge is power.
Okay, so Madison has a question. Do tumors respond to amplitude modulated electromagnetic fields or a RIFE, R-I-F-E machine?
The Rife, yes. Yeah, that is a very interesting
Do they respond
question.
is the question.
Yes. So the Rife. So where do I start with that?
Yes or no? Is it not that
Not
simple?
that simple.
Okay.
Okay, so the Rife basically was he was a scientist, and he came up with this microscope and this concept back in the 1920s, 1930s, and he had this idea that radio waves and electromagnetic waves. I can't remember if it was radio or electromagnetic. It could have been both. Were involved in disease, and he looked at these sort of things in bacteria, and he actually created this microscope and this Rife machine, and of course he was ostracized by the medical community, and things never went anywhere. There's still a lot of people that I'll hear every now and then, what about the Rife machine? It cured cancer and it's a conspiracy and everything. Well, no, it never did any good. It never really worked.
Wasn't there.
The proof wasn't there. I mean, obviously it didn't work. Otherwise, it would have caught on very quickly. No one's going to turn down a real cancer treatment that works. It's gold.
True.
No matter how hard you try to suppress it. So anyways, he created this Rife generator, and you still see people talking about it and so on. What's interesting about that is, while he didn't get any benefits from this, and this machine was thrown out, and it ended up being a big scam, the concept has actually changed on that. Not that the Rife system is any good, but the concept that tumor fighting fields has really advanced, and this has mostly been from research in Israel. And they found that definitely electromagnetic fields can influence certain cancers. And I think one of the greatest discoveries of this decade, the last 10 years, one of the best discoveries of this decade, I mean, there's been many, there's been some incredible benefits that we've come over in the last 10 years, was the introduction of what's known as the NovoCure TFF, tumor fighting fields, which has now been developed as the Optune. And this is an FDA approved treatment for glioblastoma multiforme. We're probably going to see it in other processes. And what this is they've come up with the exact electromagnetical frequency that interferes with a cell's ability to reproduce. So, there was something in Rife's original studies. He was not on it, but the concept that he came up with definitely ended up having a lot of traction. And it's this whole new, it's evolved into this whole new world. So, while he may have been the inventor of the stone square wheel, which never went anywhere, we now know that, rubber wheels are an incredible invention, and we use them all the time. So briefly, how these tumor fighting fields work is they interfere with a process called mitosis. That's the cell copying. And what they do, this Optune device has, it's basically a helmet you wear around surrounding the tumor, and it bombards the tumor with this electromagnetic frequency, which is specific to a frequency that interferes with the microtubules of the cell. And microtubules are involved in the reproductive process. Many chemotherapy drugs target microtubules, like colchicine and so on. What they do is they inhibit the formation of these microtubules. And these microtubules are basically the hands and the arms of the internal structures of the cells. So they reach out and grab a chromosome, and then they pull it over here, and then they separate the chromosomes and pull them together and so on. So they're basically the cranes and mechanisms of the internal parts of the cells. And so what happens with these microtubules is they reassemble, or they assemble and disassemble very fast. So it's like a plant that grows super fast, touches something and then pulls it back. So
Like a sea anemone.
yes,
kind
like
of.
a sea anemone, except it's a growth
Right.
and basically what it is the buildup of these alpha and beta microtubule. And so what it does is these electrical fields can interfere with this, as do most cancer drugs.
I see.
And so there's a phase called metaphase. And this is the phase where these tumor fighting fields interfere with it. That's one of the phases of mitosis. There's a few different phases of mitosis where certain things happen. And this is basically like grade 9 high school biology. You learn about this. And then there's another phase called anaphase. And that's where the chromosomes get segregated. And what happens is you have this double chromosome heterodimer. And these microtubules pull, so these are 4 copies of the exact chromosomes, and they get pulled apart like that. And so then you get something called blebbing, where the cell membrane comes in between the two cells and separates it. And so it's the division from one cell to another. So the first step is the DNA is copied. You make double copies of all the chromosomes, and then these microtubules pull them apart in anaphase. And that process is also affected by these tumor fighting fields. And then finally, there's another phase called telophase. And in this particular phase, there's a bunch of different proteins, and there's something called mitochondria. And mitochondria are the energy stores, the powerhouses of the cell. And what they do is they recharge adenosine triphosphate. So as you may have heard, adenosine triphosphate is the power molecule of all living beings. What it does is it gives away its phosphate group. So you have adenosine monophosphate and adenosine diphosphate, which is 2 phosphates. So triphosphate is obviously 3. Gives away these phosphates, and they are like money. It's like giving money. And so all of a sudden, you've exercised, you've done all these metabolic processes, and you have to have, all you've got left is adenosine diphosphate and adenosine monophosphate. You have to recharge it. So you go eat some food, and the energy from that food results in a process that adds those phosphates back to those molecules. That all happens in the mitochondria.
Okay.
And so when you affect that in the cancer cells, it affects the cancer cell's ability to grow and divide. So these tumor fighting fields do affect cancer cells. Now, of course, this is going to be based on the genetics. As you know, cancer cells have very complicated genetics. They copy many chromosomes. There's many different processes going on. And so what we're starting to see is that in patients that have mutations in certain genes, like the mTOR signaling pathway, or if they have loss of an important checkpoint called CDKN2A, those patients, this is a checkpoint that prevents cells from going past that point and going through the full mitosis cycle if the chromosomes can't pull apart or something like that. So in the case of the tumor fighting fields, it creates what's called atypical or asymmetrical segregation. So in other words, it's not an even division of the chromosomes to one cell. So, once one part of the cell will get too much of the chromosomes, the other will not get enough. And so during that process, there's a gene called CDKN2A that makes sure that those chromosomes are separated properly. And if they're not separated properly, now this is just one example, and I'm generalizing. There's many different processes, many different genes, and many different checkpoints throughout this cycle. I'm giving you a brief example using this one, molecular feature. So that ensures that the cell doesn't copy itself, and that because there's too much of one chromosome in one part of the cell and another chromosome in the other, then it says, no, you can't go past this point. You can't reproduce. We're going to break you down and destroy you. So that's what the tumor fighting fields do, is they do that. But the CDKN2A is a checkpoint that allows you to do that. So if you don't have that functional gene in place, then these tumor fighting fields will not work.
Got it.
So once again, it's down to the genetics. So yeah, this is a mechanism came from Rife, typically as
Well,
a
he was the
process.
person who originally
He originally
suggested
it, yeah.
vibrations
He
could
deserves
help.
credit.
He didn't actually say anything about cancer, to be
No.
fair. He
Yeah,
talked about
bacteria.
perhaps vibrations could affect pathogens.
Yeah, exactly.
And then people kind of took
Mhm.
it all,
Mhm.
and
Took it all.
and
yeah.
the American Cancer Association has come straight out and said that there's no merit here, and essentially
Not to the
has
Rife machine.
outlawed
Yeah.
that particular tool.
Not
Yes,
to the Rife
exactly.
machine, but definitely FDA has approved the Optune.
Yeah.
So, it's
Well, because it's a whole different thing,
it
isn't
was
it?
science.
Yeah.
Rather than just a guess, which
Mhm.
is what Rife came up with. I mean, Rife, sure, he was an early scientist, but he only had the tools available to him back then.
Yes, I know.
He was onto something,
Yeah.
but it was taken up
But
by
his machine itself
Yeah,
is
the machine,
not
no,
effective. It
no,
doesn't
definitely not.
work on the proper
No.
things. And again, you need that tumor marker profiling in order to
this
know.
is the thing. It
Mhm.
gets down to individual genetics. So here's a process where a FDA approved technology and treatment targets a mechanism or a series of mechanisms, microtubules, and obviously the
Like the
mitochondrial.
Optune, you mean?
The
for
Optune that
brain
works
cancer.
incredibly well. But if you don't know what your genetics are, you don't know if this tool is going to work for you properly.
Right.
So, we've had patients come to us and they've said, I want to do this Optune. It's, this much per month and so on. I'll get partial insurance for it. And we've looked at their genetics and said, well, based on your genetics, you may not get the best response. You may be better off putting your money elsewhere.
Mm-hmm. Right. And your hopes.
Yes.
Yes.
Thank you for watching Cetome TV. Subscribe below and stay informed.